everyone, welcome to my channel. I am Ken Esetero, a future BS Ed Math. Number help us understand the world, math help us understand numbers. And as a student, I want to explore and to know more about mathematics and ready to take my path. And today, I'll make a video tutorial deriving the two most important trigonometric formulas, which is the Pythagorean identities and double angle formulas. And the purpose of this video is to share my knowledge and challenge everyone to try mathematics. Now let's go to deriving. First we're going to derive is the Pythagorean identities. Which is there. And we have here the formulas that we're going to use when we are using Pythagorean identities. Here are the example formula, which is the sine squared theta plus cos squared theta equals 1, 1 plus tan squared theta is equal to sec squared theta, and 1 plus cos squared theta is equal to cos secant squared theta. Going to derive first the sine squared theta plus cos squared theta is equals to 1. So first we will get the trigonometric function of sine and cos. So sine is equals to opposite and hypotenuse. So we have here the opposite and hypotenuse. So sine is equals to b and over c. And then the cos is, for cos is adjacent and hypotenuse. So we have here the adjacent is a and then the hypotenuse is c. So we have here the a over c. Then we're going to ask the identities to square all of them, then add both of them. So we have here the sine squared plus cos squared is equal to b squared over c squared plus a squared over c squared. Then we're going to add b squared plus a squared and copy the denominator since they are the same. So we have here the sine squared plus cos squared is equal to b squared plus a squared over c squared. And we all know that b squared plus a squared is equal to c according to Pythagorean theorem. So we have left here the sine squared theta plus cos squared theta is equal to c squared over c squared. Then c squared over c squared is equal to 1. So we have left the sine squared theta plus cos squared theta is equal to 1 and we prove it. Now, let's have here the example to use the Pythagorean identities. So, we have here the example sines theta times tan theta plus cos theta is equal to sec theta. So, how are we going to solve it? So, we need to just put it down, the sine of theta, and then the quotient identities of tan is equal to sine over cos. Sine theta over cos theta. And then plus cos of theta is equal to c theta. And then we're going to multiply sine squared, I mean sine theta times sine theta is equal to sine squared of theta over cos of theta plus cos of theta. And then we're going to multiply again the cos theta. Cos theta equals to cos theta is equal to cos squared theta. So we left here the sine squared of theta plus cos squared of theta over cos of theta is equal to sec theta. So we know that sine squared theta plus cos squared theta is equal to 1 according to Pythagorean identities. So we will replace it 1 over cos of theta is equal to sec theta. And then the reciprocal of 1 over cos theta is equal to sec theta. So it is equal to sec theta. So we prove it. Another example. To Pythagorean identities, let's move on to double angle formula. So we have here the formula that we use to the double angle formula, which is the sine 2 theta is equal to sine theta cos theta. And then cos 2 theta is equal to cos squared minus sine squared theta, or 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. And then for tan is tan 2 theta is equal to 2 tan theta over 1 minus tan squared theta. Now, how I'm going to derive it? Addition formula of the two trigonometric functions, angles. And this is the formula that we're going to use to get the double angle formula. So, we have here the sine alpha plus beta is equal to sine alpha cos beta plus cos alpha times sine beta. Then let the alpha and beta is equal to theta. So we will going to replace alpha and beta into theta. So we have here the sine alpha, theta plus theta is equal to sine theta cos theta plus cos theta times sine theta. So, sine theta plus theta is equal to 2 theta. So, we have here the sine 2 theta is equal to, so we will going to simply rewrite this since we have here the 2 cos theta and 2 sine theta. So, we will going to simplify it into 2 sine theta times cos theta. So we will have the first formula of the double angle formula. Now, for this one, we're going to use this cos alpha plus beta. Same process, we're going to replace the alpha and beta into theta. So we have here the cos theta plus theta is equal to cos theta cos theta minus sine theta, and then another sine theta. So we have here the 2 theta, so we're going to write it into simple form. So sine, I mean cos 2 theta is equal to, so we have here the cos theta times cos theta is equal to cos squared theta. So we have here the cos squared of theta minus sine times sine theta is equal to sine squared theta. So we have here the second formula of double angle. So for this one naman, we will going to use the addition formula of tan alpha plus beta. So we have here the tan, just same process, we're going to replace alpha, beta into theta. So we will have here the tan plus alpha plus theta is equal to tan alpha, ma-replace siya ng theta, so theta plus tan theta over 1 minus tan theta, and then times tan theta again. So, we have here the tan 2 theta since duha ka po theta. And then, tan theta plus tan theta. So, we have here the 2 tan theta since duha sila. Over 1 tan theta times tan theta is equal to tan squared of theta. So, we left here the 1 minus tan squared of theta. So, we get the third formula of double angle formula. So, let's have an example. We have here the opposite 5, then the adjacent is 12, and then the hypotenuse is 13. We're going to solve this using the double angle formula. So, we have here the 2. Then, our sine theta is equal to opposite and hypotenuse. So, we have here the 5 over times 5 over hypotenuse is 13. You can make it, add here 1 to make it a fraction. So, 2 over 1 na siya. And then, times, because our adjacent and hypotenuse. So, we have here the 12, which is our adjacent, and then the hypotenuse is 13. So 2 times 5 times 12 is equal to 120. All over 13 times 13 is 169. Then times 1 is equal to 169. So that is our sine to theta. So let's have another example. Example number 2. 4 cos 2 theta is equal to cos squared theta minus sine squared theta. So we all know that our cos is our adjacent and hypotenuse, which is that 12 and 13. 12 over 13 squared minus our sine is opposite and the hypotenuse, which is the 5 over 13. And then squared. So 144, we have here the 144 over 169. 169 minus 5 times 5, 25. 169 is equal to 144 minus 25 over, copy the denominator, 169 is equal to 144 minus 25 is 119. So we have here the answer. 119 over 169. And that's it for the trigonometric formulas. Now, let's apply mathematics in a real-world situation. Now, if a tree casts a 60 feet long shadow and the angle of elevation from the end of the shadow to the top of the tree is 39.8, how high is the tree? So, if a tree casts, so let's say if this is a tree. I'm not good at drawing, but I'll try my... Okay, this is a tree. And then, the shadow, where's the shadow here? Let's say this is the shadow. Shadow. Yeah. And the shadow is 60 feet. This is 60 feet. And then the angle of elevation from the end of the shadow to the top of the tree is 39.8. So we will this is the 39.8. This is our angle of elevation. So 39.8. And then the question is, how high is the tree? So we will going to find how high is the tree. So we will going to use tangent, since we have the given here is the adjacent and the opposite. So let's have here the tan. Our angle elevation is 39.8. Our angle is equal to opposite and adjacent. So opposite is x. So we're going to find x man. How high the 3. So we have here the adjacent is 60 feet. Now we're going to multiply 60 both sides para yung maiwan na lang dito ay x. So 60 tan 39.8 is equal to x. So using the calculator, it is will be x approximately 50 feet. So therefore, the height of the tree is approximately 50 feet. And that's it. And that's the end of my video tutorial. Remember, it's important to know how to derive because it helps us to make us understand where the equation from. And I encourage you to learn math because as my experience, it is fun and challenging, and maybe it can help you to the near future. Once again, I am Ken Otero from BSED Math 1A.